Welcome to Engineering Funda family. This video is a part of Network Theory lecture series, and in this video I'll be going to explain you duality in network theory. So by using duality we can convert one form of network into another form of network. Now what are those different forms, that even I'll explain you in this video, and at last I'll explain you how we can apply duality concept to convert given electrical network into its dual network. So when you want to convert one form of network into its dual network, you should know some basic rules. Like you see here, dual conversion in network elements are like, if you have been given with voltage source, then you will have to convert that into current source. If you have been given with resistance, then you will have to convert that into transconductance, or you can have 1 by R resistance. If you have given with inductor, then with its same value you should convert that into capacitor. If you have given switch with on condition, then you will have to make it to off condition with that given switch. And if you have series connection of elements, then that will get converted into parallel connection. Now here one thing that you should understand, that is, see, whenever you have been given with values of inductor, resistor or capacitor, then whenever you form that into its dual, at a time its value will be same. Like see, if you have been given with one inductor with value 5 Henry, then in capacitance it will be 5 Faraday, right? That is how you will have to replace. But when it comes to resistor, at that time its value will be 1 divided by that resistance, or you can place that in terms of transconductance. So if resistance is of 100 ohm, then its dual will be transconductance and its value will be 1 by 100 ohm. That is how you should replace elements. Similar case which is there with voltage source. If 5 voltage source battery is given, then its dual will be 5 ampere current source. That is how you should replace elements.
It is, sir. Can I ask you one question?
Yes, John. Definitely you can ask question.
Sir, what is the dual of power?
See, John, when we talk about dual of power, then dual of power is not possible. Why? The reason is power is non-linear element. So dual is possible for linear elements only, right? As we have voltage source, current source, resistance, inductor, capacitor. So that is having a dual, but you cannot have dual of power as it is non-linear.
It is, sir. Can I ask you one more question?
Yes, John. Definitely you can ask one more question.
Sir, what is the dual of mutual inductance?
See, John, when we talk about mutual inductance, so at that time you cannot have dual of mutual inductance, as it is not considered as linear element. The reason is, when we talk about mutual inductance, at that time it is generated because of mutual coupling in between inductors, right? But when you convert that into dual, at that time series connection is translated into parallel and parallel is getting translated into series. That's why that mutual relation in between inductors will also change. So you cannot have value of dual for mutual inductance. I hope it is clear to you now.
Thank you, sir.
So as per the John's question, see, there are linear components only in duality, right? So when we talk about power or mutual inductance, at that time you cannot have dual of power and mutual inductance. Let me mention that over here. So power and mutual inductance does not have dual. Now when we talk about dual of electrical network, then star connection is having dual which is delta and vice versa is there. Nodal analysis is getting converted into mesh analysis and vice versa. When you have Norton's equivalent circuit, that is having dual of Thevenin's. In Norton's equivalent circuit, you have resultant circuit of current source in parallel with resistor and in Thevenin's equivalent circuit, we have voltage source in series with resistor. So both are a dual of each other. When you have cut set element, that will be having dual of tie set, and when you have twin, that is having dual of link. See, cut set, tie set, twin and link, that I'll explain you graph theory, so that will gives you more clear idea about it. So one very interesting note that you should note down. See, all the dual network are linear, but all linear network are not dual, that you should remember. So all the linear network are not dual, right? But dual networks are linear, that one should understand. So non-linear elements cannot have dual, right? But it is not like all the linear elements are having dual. Now I'll explain you this understanding in terms of example, so that will resolve your understanding furthermore. So let me give you one very interesting example here. So here we are deal with to convert given network to its dual network. So there are a few basic steps that you should understand over here. So see, first step, that is to make loops in given network. So let me make loop over here. I'm making loops over here, you see, and all the loops that I have considered in clockwise direction, right? Now with each loop I should give numbering, and those numberings are nodes. So this is number 1 node, let us say this is number 2 node, let us say this is number 3 node, and I need to provide one reference node outside. So here I am providing one reference node outside. Now all I need to do is I need to form its dual network. So I will be mentioning all those nodes over here. So I am having number 1 node over here, I am having number 2 node over here, I am having number 3 node over here, and I am having reference over here. Now what we need to do is we need to connect all the elements with respect to node, right? So you see how I am connecting it. So when we talk about this one node, so that is having this element 100 voltage, so that I need to connect it from number 1 node to reference, right? So here you see, now this equivalent voltage that will get translated into equivalent current source, and you see polarity of this voltage with respect to this loop, that is there from minus to plus. So current source direction, that will happen in upward direction, right? And the value of 100 voltage, that will be now converted into 100 ampere current source. So now I'll be connecting this over here. So with respect to one node, we have current source, you see I'm connecting it, and it is having direction upward. Why it is having upward direction? The reason is voltage polarity that is happening from minus to plus with respect to this loop. So this will be there in upward direction, and its value is 100 ampere. Now you see this 3 ohm resistor, so that will be connected from node 1 to reference. As you can see, I am connecting it, and it will be having a value that will be 1 by 3 ohm. It will be having a value which will be 1 by 3 ohm. So now with respect to one node, I need to connect that to reference, and its value will be 1 by 3 ohm. Or you can say that it is there in terms of transconductance, right? Now if you see this 4 ohm resistor, so that is there in between 1 and 2 node. So I need to connect that in between 1 and 2 node, and now this resistor that will get converted into transconductance of value 1 by 4 ohm. So in between 1 and 2, now I am connecting transconductance of 1 by 4 ohm. Now if you see this resistance 6, so that is happening from node 2 to reference, right? So now I am connecting this resistance from node 2 to reference, and it is resistance. So now it will be transconductance over here, and its value will be 1 by 6 ohm. So with respect to node 2 to reference, I am having transconductance of 1 by 6 ohm, right? Now you see this 5 ohm resistor that is happening in between 3 and 2. So I need to connect 3 and 2 with equivalent resistance of this 5 ohm, that is 1 by 5, which is transconductance. So in between 2 and 3 we have 1 by 5 ohm, which is equivalent of 5 ohm. And now you see only 5 ampere current is remaining. So that is happening from node 3 to reference, right? And if you see from node 3 to reference, this 5 ampere current source, that will get converted into 5 voltage. And the direction of this loop and 5 ampere current, that is same, you see. So direction of loop and 5 ampere current direction is same. So I can say that when you connect that from node 3, it should be like plus minus, and over here you see it is happening like this with 5 voltage, and polarity should be minus plus like this, right? So direction is very essential, that you should understand, right? So this is one very interesting example that we have solved. Let me give you one more problem, so that will resolve your understanding furthermore. So now you see we have been given with this network, and in this network we have switch, capacitor, inductor, right, as well as current source. So it will be very interesting to have dual of this network. So as I have told you, first step, that is to form loops with given network. So I am making loops. You see this is first loop, this is second loop, and this is third loop. Now with these loops I need to make nodes. So I am saying this is node number 1, I am saying this is node number 2, and I am saying this is node number 3. And after that I need to place one reference node. Now all I need to do is I need to draw its dual over here. So what I will be doing is I will be writing nodes over here. So this is node number 1, node number 2, and node number 3 over here, and here we have reference node. Now we are deal with to have a connection of all the elements which is there in circuit with its dual, right? So let us start with this first element. So if you see this R1, so that is connected from node 1 to reference, right? So I am connecting that from node 1 to reference, and its value, that will be as per 1 by R1, right? That will be transconductance. So its value will be 1 by R1. So from node 1 I need to connect that transconductance, that is having value 1 by R1. Now see this Vg, that is been connected from node 1 to reference. You see I am connecting it, it is connected from node 1 to reference, and it is having now current source Ig, which is having value Vg, right? So current source is having value Ig, which is similar to Vg, and if you see this voltage source with respect to this given loop, then this voltage source is happening from minus to plus, means current direction, that should be upward direction like this, right? So from node 1 to reference I need to connect current source. So you see I am connecting node 1 to reference, I am connecting one current source, and this current source is having value Ig, that is equals to Vg, right? And its direction is upward. This is very essential. You will have to see loop direction. If it is happening with minus to plus polarity with voltage, then when you draw it over here, at that time it should be there in upward direction. Remember this. Now see this switch is there. So this switch, that is connected in between node 1 to reference. You see I am just making it over here, and when you draw this switch, right, at that time all you need to do is you will have to see whether this switch is getting open or closed. So you see this switch, that is getting off over here, right? So here I need to make it to on. So now I will be connecting switch in between node 1 to reference. Only difference is now I'll be making this switch on as it was getting off with this circuit, right? But now in its dual it will be getting on. Now I'll see this capacitor which is there in between 1 and 2. So you see now when you draw dual at that time in between 1 and 2, this capacitor, now that will get converted into inductor, and the value of this inductor, that will be C only. So now in between 1 and 2, now I'll be connecting inductor and its inductance value, that is equals to the magnitude of C, right? Now if you see this inductor L2, so that is connected from node 2 to reference. Let me show you how it is connected from node 2 to reference. So you see it is connected from node 2 to reference, and this inductor L2, now that will get converted into capacitor C2 and its value will be L2 only. So from node 2 to reference will be having connection of capacitor, and value of this capacitor C2, that has to be L2. Now you see this R3, that is there from node 2 to reference, I am connecting it. It is there from node 2 to reference, and this R3, now that will get converted into transconductance and its value will be 1 by R3. So now from node 2 to reference will be having transconductance, or you can say its value, that is 1 by R3. Now you see this R2, that is there in between 3 and 2, right? So now I need to connect this R2 in between 3 and 2, and its value, that will be now 1 by R2. So in between 2 and 3 we have transconductance G2, that is 1 by R2. Now if you see this L1, so that is there in between 1 and 3, you see this L1, that is there in between 1 and 3. So instead of this, now I need to replace that by capacitor, and this capacitance value, let us say C1, so that will be L1 only. So in between 1 and 3 will be having connection of capacitance C1 and its value, that will be L1 only. Now you see we have I0, right, that is connected in between node 3 and reference, and if you see direction of I0, that is opposite to the direction of loop, right? Loop is there in this direction and I0 is there in this direction. So both are there in opposite direction. So when you connect voltage source V0, that is equals to I0, so it is having minus plus connection as direction is opposite, right? So in between node 3 and reference we have voltage source which is V0, that is equals to I0 magnitude, and polarity will be minus plus. So this is how we have dual network, you can see over here, right? So I hope now it is clear to all of you like how we can identify dual network based on given network. And still if you have any query, you just place that in comment box. I'll be happy to help you. Thank you so much for watching this video.